Hello everyone, I'm welcoming you all once again to this channel. Today I am going to make a video on the Gaussian software where earlier we have also done so many calculation using this Gaussian software. So today I am going to make another video where we will see how to do the calculation with temperature and without temperature. Like if we want to calculate something at a particular temperature, then how to do that. So mainly those thermochemistry thing we will see today. So first we will see how to write the input file for with and without temperature. So here I am going to open the without temperature input file first, and here you can see that we have taken this OPT frequency. We will optimize the structure first, and as well as we will calculate the frequency in the same file. And here we have taken this B3LYP functional and this Gaussian basis set of 6311 plus GDP1, and it has a geometry having connectivity among each other, like all the atoms are connected to each other. So this way we have written, this is very simple Gaussian input file. So what if we want to write with temperature, then how that input file will look like. So here I am going to open the file with temperature. So here you can see that same thing we have, and apart from that we have added this pressure equal to 1.0 atm, and next to that we have added this temperature equal to 423 point, like it depends like how much temperature you want. So I have taken one particular value. So this value is in Kelvin. So if you don't want to take your temperature at a certain range, so and you are calculating the frequency, so Gaussian will calculate it as at 298.15 Kelvin and 1 atmospheric pressure. So if you want like 300 Kelvin, so that is typically 25 degrees Celsius. So if you want it to be at 27, then 300 degrees Celsius you need to write. If you want to calculate it at 150 degrees, so you need to write this number. So this way just you need to add 273 Kelvin into that, then you can write that here. So this way we can write the input file for with and without temperature. Now I am going to open the same file using our GaussView. So I am opening this GaussView here, GaussView without temperature. So you can see this input, and here I am going to open this calculate. You see here, like we have chosen the job type as OPT frequency, then here we have made all these default setting. Next in the method section we want to find out the ground state, then DFT, then using B3LYP functional, then this basis set we have chosen 63111 plus 11 GDP plus GDP plus, then this is the charge zero state, that is neutral state, and having the spin singlet multiplicity. And this way we have written the input file, and how many processor you want to choose, that also we have given. So this way this is a very simple input file. And similar way, if I will open that with temperature input, so that will also have a similar kind of structure, rather little difference in it. So you can see here, so in the additional keyword we have added this pressure 1.0 and the temperature 423.15 Kelvin. So this is the only additional value that we have added here, and it is reflecting over here, you can check. So here only without temperature and pressure, and here with temperature and pressure. Now what if we want to check the output file of both of these? So there we can see, so I am opening the without temperature log first. Let me close this too. So this is after optimization, and here I am going to the result. You can see here that the OPT, like here everything is conversed, and in the thermo setting we can see that the temperature is 298.15 Kelvin and pressure is this much. And here you can see that what is the 0 point energy correction, what is the energy plus thermal energy correction. So every value you can find it from here, and the entropy value you can get it from here, and like the the original energy, like without taking care into without taking the entropy value into consideration. So this is the normal optimizing energy. Okay, next I'm going to open this with temperature log file so that we can compare both of these results. So here you see that here also we have same energy. You can see that when we are adding temperature into a Gaussian, that doesn't mean that we are doing the molecular dynamics like what we usually do in using DFT. We can use AMD, and using lamps and other tools we can do MD. So there we see how the structure evolves with temperature, but here either structural evolution we can't see, rather we can only do the thermochemistry. Like if you want to add the entropy term, like entropy term itself come with one temperature factor like T delta S. So if we want to add that value, then only we can do this thermochemistry. Here you can check comparing to both of these. Here the temperature was 298.15 Kelvin and 1 atm, and here as we have modified the temperature value, now this modified temperature value is showing up in here, and everything is same, rather only this entropy term might have some difference. You can check over here. So here the E thermal energy is different, and here this E thermal is different because of this temperature factor. And also this entropy value, you can see this entropy is 108.006 and here 121. So only all these things are coming because of this like this change in temperature. And typically when we do this thermochemistry, then we utilize this particular value where this energy plus the thermal energy correction, like thermal free energy correction. So we choose this quantity for further calculation, and here similarly we can compare both of these values. You see that this is 3185.790250, and here it is 3185.813210. All are in the Hatry unit. So this way we can do this calculation at different temperature just to check their thermochemistry, how it is varying with different temperature value, and that's it. We can't do any molecular dynamic simulation, rather we can simply extract their energy values and do further calculations. So yeah, so this much for today's session, and thank you all, and bye bye.